So we're in the post webinar now. For those of you that wanted just 3 hours, you have received that. But those of you that want to stay and have a Q&A with chat with Paul, we can do that. We can do that through the questions and answer dashboard that you've been using very well today. Also, if you want to raise your hand, we can do some other fun things too and find that out. All right, let's take on the first one. Have you seen issues with the RCC spillways that have been added to earth embankment dams years after installation?
Yes, I have. In most cases, they performed very well. But like all auxiliary spillways, they're designed to be activated so infrequently that we don't have a lot of data yet. But what I have seen, for example, the one in Texas, Umbarger Dam, when they placed the RCC lifts at that one, and when there's a lot of thermal effects where the sun will beat down on that and heat up the surface. And they didn't have, in some places, really good adhesion of the RCC lifts. Roller compacted concrete is placed in 1 foot thick lifts, one lift at a time, one on top of the other. So you're just standing between one on top of the other on top of the other. And what they experienced at that project was delamination of some of the lifts where they'd expand and then they'd buckle. And so that's kind of a lesson learned, that in some of these cases, we need to have bonding mortar between the lifts, especially at the top, where they're more free to move. So I've seen that. What else with RCC? If it's not, I mean, the typical things, you want to have an RCC mix that doesn't segregate. And if you're placing it and it does segregate, you're going to get a lot of surface deterioration. But most designers will build that into the design and they'll call it sacrificial. Probably the biggest problem I've seen is the sponsor or the people that frequent the site, they look at the roller compacted concrete and they expect it to look just like conventional concrete, when it's not. It's a totally, although the ingredients are the same and you may end up with the same product, the surface treatment is a lot different. You don't have forms and you don't finish it like conventional concrete. Now, I've seen some RCC projects that are amazing. It's almost hard to tell them apart. They have a lot of paste in them, and there's a lot of work with that. They have good forms, and they do a good job compacting. But there are others that don't weather as well, and they look pretty rough. But it doesn't affect the performance of the spillway as long as that's built in as part of the sacrificial part. And the only other thing I would say is the cracking. Roller compacted concrete is not reinforced concrete. So it's free to crack. It is rigid and it will crack, but that's okay. Now, the key is that the drainage layers that are underneath should have been designed to accommodate that as well. So generally there's like that gravel layer and then the finer material. If you had that fine material immediately underneath and there was cracking, there'd be the potential for that to, pipe out and stuff like that. So those are some of the things I think with roller compacted concrete that I've seen.
Mm-hmm. Very good. And we found the unmute button. It must have been on my end, Lisa, for your closing comments too. So we're going to slip those in right now, come back to questions. Lisa?
I just want to say thanks so much to Paul for the presentation and lots of great information out there. Again, if you all like what you're hearing from these webinars, please continue to tune in as we have them periodically around through the calendar year, and continue to consider being a member of the National Watershed Coalition. Paul, great information, and we greatly appreciate you.
Well, thank you, Lisa. It was a wonderful experience.
Thanks, Lisa. All right, we're going to move to some more questions. As long as you don't need a break, Paul, we'll just keep running on rolling. Yeah, we got 100 and so folks still joining us in our extra innings. I love baseball, so we're going to play some extra innings here. So was it Willie Mays that said we like it so much we'll play two, right? So could I use your presentation? This is directed at you, Paul, or some parts of it for sponsor education material?
Sure. Now you have the PDF version, but if you need specific slides, let me know. The one thing I'd warn you about is this thing right now is at 2 gigabytes. So it's not very, it doesn't work on everybody's system. You need a pretty decent computer and a lot of file space to store it. But yeah.
And probably the PDF version doesn't include those nice videos that you embedded in there.
Right.
Yeah.
They don't, but it is high quality. The PDF version is the full slide high quality.
Okay, thanks so much. And I just as a matter of courtesy, we would hope that you would put, you know, some note about where those slides came from, huh, Paul? I mean, that's
sure.
A lot of work you put in that.
Well, I think you know where they came from. They came from Danny McCook. They came from Daryl Temple. They came from other class participants. And I'd like to, anyone out there, I bet you saw your name on some of those slides. And it's a community of the National Watershed Coalition and others just sharing their own experiences with me so that I can share them with others. And if you look and go through it again, you'll see that probably half of the content or more is coming from you know, others. And a big thank you to Larry Caldwell, because you know, and the work that he did, that was just a great resource.
Yeah. Okay. I'm going to switch gears with you now. We've been talking about some logistics, so let's talk about more about the engineering. Do you consider ACB a structural solution for the auxiliary spillway?
I consider them not only a solution for the auxiliary spillway, but for dam overtopping as well. And I know the NRCS draws the line there. They will allow them to armor spillways, but they will not allow them for embankment overtopping. I think they're very cautious. They want to see it proven, you know, tried and true. I've had the advantage of, I was in Puerto Rico. In fact, I'll share that while we're doing stuff. Let me find that real quick. And if I'll share my screen as soon as I get it. Okay. I'll show you an embankment dam that was 50 feet high, that was armored with articulated concrete blocks, and that was overtopped 11 times, and it was overtopped by as much as 6 feet, and it performed well. So that's fairly new stuff. And I'm hoping that someday the NRCS they might consider it as a solution. But again, err on the side of caution. I understand that. And I'm almost there. Here we go. I think I've got it. Nope, wrong one. Just take me a sec to find the right. Maybe you could give me the next question while I'm doing this so I don't hold people up.
This one is regarding the problem with heat of hydration with RCC. How do you manage that?
Well, that's the beauty of roller compactor concrete. With conventional concrete, you're really focused on getting that concrete as strong as possible so you can remove as quick as possible so you can remove the forms. And that's why we're so interested in the 28-day strength. But if you want early strength, that means you want that chemical reaction to happen as quickly as possible. And if it happens fast, then the heat of hydration becomes an issue. But when you're building with roller compacted concrete, there are no forms in most cases, and you're really not interested in high early strength. So like you are in a bridge deck, you want that bridge operational as quick as possible. You don't want to wait a year for the concrete to harden. But with mass concrete, you really don't care how long it takes to harden. You just want it to stay intact and be a gravity section. So when you have roller compacted concrete, you remove a lot of the Portland cement, which is the primary source of the heat of hydration, and you substitute fly ash. And fly ash and Portland cement, there's some magic that happens. When fly ash comes in contact with Portland cement, it basically becomes its own cementitious, it is an equal to Portland cement. It becomes Portland cement, but it happens much, much slower. It takes the chemical reaction is continuous and it's slow, so it doesn't generate a lot of heat. So that's one of the wonderful things about RCC. You manage it with fly ash, and you don't get the high heat of hydration. And I found a couple of slides here. They're not the very best. If I could share my screen, is that okay, Ray?
Yeah, fire away.
All right. And you tell me when you see it.
Yeah, coming up right now.
All right. I'm actually standing on a downstream dam, and this was a temporary coffer dam in Puerto Rico. And this was a Corps of Engineers flood control dam because this watershed was so flashy. And they needed to build an upstream coffer dam to protect the work. So they took this embankment, and so here's the dam that's downstream. And then this was the coffer dam upstream, and here's the foundation of that dam. And then that's the foundation, there's the coffer dam. And this was the temporary coffer dam. It was 2-to-1 slope on the downstream side, steep slope, 50 feet high. And they tested the blocks in a flume under the exact same conditions. And then they placed the block mats on the surface. Now, I won't get into some of these details, but they did a lot of things wrong. But it still showed, this is one of the 11 times it was overtopped. And you can see the hydraulic jump and the standing wave here, and the amount of energy. And there was some damage at the toe. And I attribute that mainly to the details that they used, but it still worked. The embankment never eroded. So I'm pretty excited about this technology, as long as the devil's in the details.
Excellent. The next question, I think Dan's typing an answer here, but what is the NRCS argument against ACB for overtopping?
Well, and I understand it too. Embankment armoring is a solution of last resort. If you were building a new dam, you would not design it to be overtopped. You would build a spillway to left or right abutment, or you do something, but you would not design, that's unacceptable. So we start there. So you look for other alternatives. If you have other alternatives, you use those. And then if you are going to armor the embankment, they accept roller compacted concrete right now. That's a pretty robust, reliable design. I just don't think they've reached a comfort level with articulated concrete blocks. I can show you embankments that have also failed that have been armored with articulated concrete blocks, but I truly believe that they're related to the details that were used. Just to make it simple, the engineers that I think were designing those systems, one is they were using the wrong blocks. All blocks are not the same. And two, they were using channel lining details and not embankment overtopping details. It's really apples and oranges. And I could say the same thing about roller compacted concrete, I guess. If you use the wrong details, you can still have a failure. I mean, look at Oroville Dam. That was a reinforced concrete spillway. It failed. Should we stop using reinforced concrete to build spillways? No. We just got to pay attention to the details.
Very good. Very good. Well, we're waiting for additional questions to come in or hand raises to come up. If there are something that you want to ask Paul and have a verbal back and forth, that we can do that now that we're down getting into the hundreds. We can probably do that for you. So keep those questions and answers coming. Hey, Dan, one of the big things that has been coming up both in our questions and answer area has been what to expect about the follow-up, the links to materials and the recording and things like that. Do you want to cover that verbally with the folks?
Sure, Ray. Usually that takes us 5 to 7 days to get those things in place. I think the last webinar we did, we actually had a 24-hour turnaround, but I think you can probably check our website in the next, let's just say the next 7 working days. And there should be information up there about where those can be found. Again, the recorded webinar will be available on our YouTube channel, so you can go there and see it. We also had a couple of requests for the basic presentation files that Paul used, and he's been gracious enough to share those with us, and we'll make those available as well.
Okay, thanks, Dan. That's appreciated. And thanks, Paul, for allowing us to share those back with the participants. Keep those questions coming. Raise a hand. Do whichever you would prefer. Happy to cover those. Let's find out. I think I've got a hand raised here. Let's see if we can add here one or two speak. So go ahead, and I hope I pronounced your first name correctly. Adhere?
Yes, thanks. I'm with NRCS Connecticut. I'm a state conservation engineer, and one of the things that I'd like to do is educate our sponsors, and that's the reason I asked that question. So if I could have a box created, and if I could download there or find some way of doing that, I would appreciate that. I'm sure that you have a lot of material, so I might have to cull that. So using presentation would be better than trying to work with PDF, if that's possible.
Sure. Some of that, have to be careful. Some of the presentation materials are part of an ASDO seminar.
Okay.
And that's something that's offered about twice a year and things like that. So I may need to get permission from them, because they paid for the development of the materials. Right. They may not appreciate it if I hand them out.
Oh, that's fine. And again, that's the reason I asked the question, whether it's even okay to use it. I don't want to go ahead and assume that it's okay to use it. I realize that there are copyrights and other things, so I don't want to do anything that will violate any of that stuff. Right?
Okay.
Good.
Yep.
Hey, Ray,
yes,
there is one other exciting development with these articulated concrete blocks. Just like all the technologies that are out there, people are making investments and they're doing more and more. Something I'm really excited about is they've had a major breakthrough, and they're now using a foundation stabilization feature under the mats that I think have taken this to the next level. You see it here at the geocell with the geogrid on top, and then the geocell is filled with gravel. So this is what that geocell looks like. Then they fill it with gravel, and here they're putting it on the slope of a spillway or an embankment, and then they're filling it with gravel, and then they put the geotextile on top, which is a geogrid, not a geotextile. You can see right through it. You see how sheer that is. Then they put the blocks on top of that, and then we lace the whole thing together so that it's just one continuous carpet of blocks, and that's the lacing. And then we fill all the seams with backfill concrete and reinforcement, so that it's one continuous system. It's not just individual blocks sitting there. And here's an example of an embankment that was armored with that, and all the seams being filled in. And then we just topsoil, we fill it with pea gravel, and then you can topsoil and seed it. And this one was activated 2 months afterwards. So here's the finished project. And then it was activated, and the grass didn't have a chance to really grow, but it just eroded some of the topsoil and the grass cover. But it worked really well. I wish I had a picture when it was really, really chugging. But what this solves is you can have a hydraulic jump on the surface, and it was tested in the laboratory with a full hydraulic jump on it.
Okay. So a couple of things here. Shane came in with a question, and I think you might have just answered it. Do you have any experience with GeoWeb geocell materials and their effectiveness? So I think you probably just tackled that one. Paul, anything to add to that?
Well, that's exactly, he's ahead of me there. That's exactly what was going on there. And in fact, I'm using it almost exclusively on all the projects that I use. Here's where they induce the hydraulic jump on that 2-to-1 slope, and to test that. And when you don't have that treatment underneath, they found that these blocks were stable up to about 1.5 feet. When you got to 2 feet of overtopping, then they became unstable. Once they put this under treatment underneath, they got about 5.5 feet, or here 5.3 feet, which was the limit of the flume on a 2-to-1 slope, and they couldn't get the system to fail.
Yeah.
So I'm excited about that.
So Alton had a question about the presentation on ACB. I know we're not changing the slides here. We've got that nice place there. Let's get Alton in to talk with you what it is. Dan's saying he can't see the slides that are being presented. I'm seeing
Oh,
them.
did I not share them?
I'm seeing them up here on my machine, the depth of overtopping
Okay.
4 feet. And I don't think that you changed those slides if I'm not mistaken. So Alton, did you have something else to say with Paul today? Got you unmuted if you want. Not shared out here is what he's saying. I'll be darned.
I'm going to share it again. So I'm resharing.
Yeah, there you go. Coming back up. It's changing here and on mine, and hope it's changing out there, Dan, on yours. Let's check with Dan.
Yeah, I can see it now.
Okay, good. All right. So hopefully one of the difficult things for Paul, Dan, and I is we can't really sit there at your computer if it's not on our end. So we're apologizing for something we can't help with. But thanks, Paul, for changing that slide over. All right, let's go to another question. For aging earthen dams with seepage that cannot be effectively predicted or controlled, are vertical cutouts a good option or a last resort?
Vertical cutouts, I think, is like trenching and trying to put in a drain. Is that, I'm not sure exactly what a vertical cutout is. There are different ways to skin that cat. One is to put in a cutoff inside the embankment. And you can do that like a cement bentonite cutoff wall, or with the wind system where they come in with the giant. I can show you where we've done that on a couple of projects, where you go in with a giant chainsaw and you replace the material that you're taking out with a cement bentonite or an impervious wall.
Sure.
So that's a good way of creating a new cutoff, but that doesn't solve the, how do you filter the seepage, right? So that might address the seepage, but then you still need to filter the seepage. And all of the examples I've seen, you basically strip the downstream slope of the embankment and you apply it to that slope, almost like a blanket drain. And then you make sure there's enough topsoil on top to make sure that it's stable. I'm not aware of anybody trenching in and building it except like a toe drain.
Yeah, let's get John on the line here. Hey, John, you want to follow up on that question you had and Paul's response? Follow up.
Yes, that'd be great. Yeah, I think you hit part of the nail on the head. Kind of the vertical cutting through the center of the dam and adding that bentonite slurry or some kind of concrete slurry. And in some cases, I've seen, it was a ASDSO presentation of actually putting in a mixture of some reinforced concrete panels along with some slurry around that. So, those are, I think that was in a karst situation, but I guess it's probably hard to hit every situation, but these, especially NRCS dams that are aging, and some situations where I guess the expense of trying to control all the seepage of these cutoffs would be an option.
That's another technology that's relatively new. I'm trying to really quickly pull up an example where I could show you what that looks like, because it's truly amazing. We did one project up in Ohio, Buckeye Lake Dam. That was a dam where there was about 375 homes built on the dam, going back 100 years. And every time a home would burn down in the community, it was the dam's on fire and it could breach. So it was really kind of critical. And the solution there was to build a new dam upstream of the existing dam. They basically pushed in a fill material that was sandy, granular type material. And then after that was built, they built a cutoff wall through it by making about 3 passes. This cutoff wall ended up being about 3 or 4 feet wide, and it went down about 30 feet. And every time they made a pass, it was 3.5 miles long. And so I've got to find a couple of pictures to show this. But they just started at one end and started cutting through that new embankment and mixing Portland cement with that gravel that they had placed and left behind a concrete wall. And then they overlapped it again and again and again, and then they cored through it afterwards for quality control. So amazing technology.
Yeah, that was going to be a kind of a follow-up question of maybe situations where initial installation of 50 some years ago that the filter maybe wasn't designed to be compatible with the zoned fill, and possible options where maybe this cutoff could use.
Yes. Yep. A good geotechnical engineer, can help you solve that problem.
So that name of that location that you're looking up with the dams and the houses, repeat that one more time, Paul.
It was Buckeye Lake, and I found it here.
Well,
I've only got one slide, but you can see here this was the dam, these houses, literally. The front yard.
We'll have you come back up and share again.
Well, you can't see it. Okay, I'm going to try.
Mm-hmm.
All right, we share.
Yep, reshare. Here we go.
And share.
Yep, it's coming through now.
Okay.
Thanks, Paul.
All right, so you see the homes. That is the dam. These homes are the dam. The front yard was the crest of the dam.
Mm.
So they came in with a granular fill, sandy gravel, and placed that first, and placed a riprap on top, and then came in with the trenching machine. And you can see that. Well, this is one type where they came in and drilled holes and did it, and the other type was that big chainsaw that you just kind of lower it into the ground and this starts mixing. And they had these actually 2 systems competing, and whoever could do the best work the fastest got paid the most. So it was like starting the railroad tracks from the west and the east, and whoever laid the most track won, and got paid the most because you got paid by the track. So it was a really interesting competition, and both systems worked really well.
Very good.
I'll keep looking for that DeWind one. I'm just trying to find the right example.
Folks, keep those questions coming in on the dashboard there, or raise your hand and have a conversation with Paul. Either way is great. Again, Paul, thanks so much for going extra innings with us and making sure that we answer these questions, have a dialogue. Ed here says, when you say chainsaw, I'm a picture similar to a ditch witch, right? And I think you had a picture of it up there. So
now I really have to find it. I'm going to just type in DeWind on my internet search.
Sure.
And see if I can find some good pictures, images. Okay, here we go. I'm going to share my screen, and anybody can do this. I've got some great pictures, but I just can't find them fast enough. Well, here, let's do this. Do you see my screen?
Not yet. Fire back up.
I'll have to reshare.
Yeah.
Okay, share.
You're back on. Yep.
I'm looking here. It looks like there's a good video. I'm gonna do that. Want to see what happens. So I'm at their website and see. Okay, let's try this one. No. Oh, forget that. Looks like I'm getting too many ads. I'll save everybody the ads, but see if I can find a good example here. But there's kind of, you can get a sense of what the machine looks like. Here's the chainsaw part that digs into it. I'm going to go back and see if I can't find a better picture.
And as you're doing that, folks, don't
Yeah,
be
there you go.
shy. We've got an opportunity. Raise a hand, have a conversation, ask a question, do whatever. Question and answer dialogue or the raise hand feature. Yeah, go ahead, Paul.
All right. Do I have to share again?
No, it's up on the screen there.
Okay.
Let's see if it'll.
So that's kind of a chainsaw that it looks like a chainsaw as you're inserting it, and then it goes vertical, and then they just rip along, and they mix the material with the concrete and they sample it as you go to make sure you get what you want. But, yeah, in fact, I think this is what they used at Buckeye right there. Yeah.
Yeah, very nice. That's some pretty impressive technology there, isn't it?
Yes, it is.
Yeah.
Yeah, if you got a, this is a good solution if you have a dam with a lot of animal damage.
Mhm.
And you need to reestablish the core. You can put in a concrete core or something that the animals can't chew through, and at least you'll have the peace of mind that there is this becomes the dam, and then the upstream and downstream sides become the shell that support the core. But this because it's basically like a concrete core wall inside a dam.
Excellent. Keep those questions coming in. Raise your hand if you want to have a conversation with Paul about something that was shared today. Happy to unmute you and have you do that. The question I have for you, Paul, is not necessarily dam related, but somebody checking those ribs for you so they don't burn?
I went down the last break. We're in good shape.
Okay. All right.
But thank you.
Yeah. And then, of course, one of the questions was, have you got enough for all of us? And we answered that, I think.
I live at 50 Circle Place, Camp Hill. If you can come over in the next 2 hours, help yourself. I'm making lots.
That's exceptional. All right. Looking for that last hand raise or question coming in from the questions dashboard. Either way is fine, folks. Don't let this opportunity pass you by. This is a real treat that Paul has given you today.
And Ray, I correspond with people all the time. So you can share my email if anybody has a follow-up question. As I have time, I'm happy to help out.
If Ed here, and as an example, we'll get a hold of Dan or myself, and we'll make sure. We know you don't need to be inundated with a lot of emails. Michael, thanks for your note. Kudos have been coming in right and left, Paul. So many, too numerous to count even, of the great presentation, the great training, wonderful information shared. And Ed here, we'll be doing that privately with you rather than sharing with 100 folks. Paul's email, I think it'll be better that way. Richard, Rick, thank you so much for your note here in the Q&A piece. We appreciate that very much. Anybody with a question and or a hand raise here, great opportunity for you. You just this opportunity to have Paul present and to do this extra innings is pretty phenomenal. While we're waiting, Dan, other things that come to your mind that we should be covering?
I think on the O&M front, we're good. It is our hope that sometime in the coming year, we'll be able to have an in-person hands-on session that will cover some of the nuts and bolts of operation and maintenance, the equipment that's used, and so on and so forth. But as everyone knows, public health concerns have kind of disrupted that flow, but we hope in the coming year that we'll get back to being able to do some in-person things. And can't say enough how much we appreciate Paul, and we appreciate you all for hanging around and sharing insights with us. So thanks much.
Thanks, Dan. And we did get another question here, Paul, if you're willing. Have you ever seen the finished project in Oklahoma where the spillway swirled into the dam upstream of the road? And I'm going to unmute Rick just in case he wants to give more information here. So,
I'm having a hard time visualizing that. Sounds very interesting.
Yeah. So Rick, come on the line here and give us a little more information that Paul can talk to. We got you there, Rick. Hopefully you got a microphone there nearby you or on your machine. Got you unmuted, but you may be muted on your end. Again, the question that Rick asked is a finished project in Oklahoma. Are you with us, Rick?
Can you hear me now?
Yay, we got you. You got you.
All right.
Thank you.
Hi,
It
Rick.
was a picture you showed in your presentation this morning of the site where the spillway was flowing, had a road downstream of it.
Yes.
And it's caused the swirling into it that was cutting back through the dam, almost cut through the crest of the dam.
Right.
And I was wondering if you had seen that after it was finished, after we did the repair on it.
I did not. No, tell me about it.
You can find that on Google Earth of all places, some really good pictures of it.
Yeah.
It just shows up nicely there for some reason.
You want to share it to us? I can
I
make
can
you a
type it in here if you.
share.
I would have to hunt it up for a few minutes, but it was a Sugar Creek site. Let's see if I can find that right quick for you.
When you
I'm
do,
gonna-
I'll put you on.
If I can, I will share it. It may take me a few minutes.
Yeah.
I'm racing you to it here, so I'll share
Okay.
my screen too. And you just tell me. When I share my screen, are you seeing it? Are you seeing Google Earth?
Not
I'm
yet.
not seeing it yet.
No,
Not yet.
we'll probably have to have you come out and come back in. Now you got Google Earth. Yep. You got something coming up here.
Okay, I haven't got it yet
Okay.
on your end. I'm not seeing yours yet.
You're not.
Not yet.
Not yet. Mm-mm.
Okay. Why is it not showing?
I'm not sure. I'm still.
Because I shared. Let me try it again. Because I'll stop share. Oh, screen sharing has stopped as the shared window is closed. Okay, let's try it again.
Mhm.
And
And you're not sharing anything now.
I'm working on it.
And I got you, Rick, over as a panelist. So if you find it first, then
I figured out what I was doing. I was sharing the app and not the screen.
There we
So,
go.
but here, Sugar Creek, it's Oklahoma, right?
Yes. And I will get you the exact site now. I keep forgetting, we had two sites we worked on, L43 and L44, which meant they were laterals. And I keep forgetting which was which on that. We worked on both of them, so I have to look it up every time.
Do you have a community
Rick,
where it was there?
Yes, it's just north. It's just north of
This is Dan
Anadarko.
Siebert. I believe it's L44.
I think that's correct. L44. It's not in that part of the world. It's out in Caddo County.
Oh, sorry. That's Arkansas, Oklahoma. Here we are.
Yeah. Further west.
Clinton.
Anadarko. Anadarko.
All right, a sec here. Anadarko.
Yes.
Got it. Okay.
And let's see.
Just a shade east and a hair south.
Now you want to go just north and just west of there, excuse me, the other direction.
Northwest, right?
Yes. Go north.
More north?
Yeah. Zoom out a little bit and we'll be right exactly where you need to be.
Is that it?
That's not the one.
Anadarko, right here.
Yeah. Okay.
North.
Go a little further north. Pull that screen down a little further. Well. Okay, just north of that casino.
Is this is the casino, north of the casino? Okay.
Yeah, and okay, and now go west. A little further west. It's show up here in a minute, I think.
Is this it?
Okay, there. That's it.
All right.
And do you know how to go back in time on Google Earth?
I sure do. Look, I'm just kind of absorbing. Boy, that's something, isn't it?
If you look at this, you get a funny effect on that 3D. It looks like the road sags, but the road goes straight across. We actually put a box culvert under the road for the auxiliary spillway, and that's cut into sandstone. But if you go back in time
Oh,
to before we
Oh.
did the, you have to zoom out a little bit there. This was during the construction.
boy, you rebuilt the whole dam.
We actually moved the dam. The dam used to be up. You can see where it used to be upstream there.
Oh, yes, yes.
And when the road was there and it was blocked, when the spillway functioned, it filled that
Yes.
area up and the road failed. And when the road failed and all the water went, the back toward the dam was saturated and it just started sloughing.
Hmm.
I think about okay, you need about one more step back to be in the area right before it happened.
Mm-hmm.
Okay, this is before the storm.
Right.
The dam was just upstream of the road.
And then it happened.
And then in summer of 2007 happened. We had actually had an inland hurricane that year. It sure looked like one.
Hmm.
Big storm swirling over the state with an eye and everything.
It looked like the dam was actually deliberately breached too, right?
It was, by this time it had finally been breached. First, we tried to breach some of the spillway to let the pressure off. And then well, this is actually the spillway area has been breached to take the pressure off. And then they cut out some area.
Mm-hmm.
Just to keep from having so much water behind it if it did fail. Then we went in and did the reconstruction.
And you built the road right across the crest of the dam.
And yeah, we moved it downstream, and in conjunction with the highway department and the county and the state, we they had to rebuild the road too. And so they rebuilt the road right over the top of dam. The extra width for the bulk was paid for the road expenses. To get over the auxiliary spillway, we just built it's a concrete box culvert bridge, about, I believe, 3 boxes, if I remember correctly.
Nice.
And one of those creative solutions that so far is looking pretty good.
Mm.
It was interesting to listen to you guys talk because the question and answer area was lighting up with everybody that found it, on their machine so quickly. But it's like spelling and mathematics you never want to do in public, right? And so yeah,
It's slow. It's
Yeah.
slow trying to think under pressure.
Yeah, it is. But excellent.
Yeah. In 40 years, I've tried to do a lot of presentations, and it's much better until someone's listening.
Yeah.
Your practice sessions are always better than the real thing, huh?
Oh, much.
Oh, my
But
God.
anyway, I
Thanks,
just
Rick.
wondered if you had seen that, because that was really interesting to me that slide showed up. That was one of our more interesting projects.
Well, it was one of it's because of that. Well, actually, I'll show you something else here. When Danny McCook showed that to me, I had to sit down. I said, whoa, I never even thought to look at that. We do assessments, we do dam inspections and all that stuff, but I never thought to look for that. And I'm going to show you after that, I started looking at other projects and I started seeing that same thing happening over and over again. It's just that it was not the primary failure mode, but it would have happened if it continued. And I'll just show you 2 examples.
And while Paul's bringing those up, just to remind you folks, we're in extra innings here. This is a post-webinar discussion with Paul. If you want to enter into that, please do put something in the question and answer, or just raise your hand like Rick did. And great conversations going on here. Thanks so much.
Ray, am I still sharing?
Yep. I got
Yes.
2 people standing about ready to fall off a berm there, it looks like.
Okay, Ed Fiegel, who was the head of dam safety in Georgia, sent me this one. And this spillway breached, but look at the flow, how it's coming back, and it took a bite out of the dam right there.
Hmm.
So the same thing, but this one won first. It failed here before it failed here, so nobody paid too much attention to that one. And then this one from Darrell Temple, it breached through the spillway, but look what the flow was doing. It was coming back, and it was also taking a bite out of that dam. This one happened first, that's all.
I would have a theory that the material that was coming out of the spillway was going downhill to where it hit, and it was piling up and kicking the water back.
Okay.
the water was doing what water does. It was running a serpentine pattern to try to get a smoother grade, a flatter grade. It doesn't like that steep flow.
No.
It
No.
just, but ours was caused, as I said, there was a road downstream and it had a big, it was blocked. So we had a big impoundment on both sides of the dam. Then when the road failed, it let all that go and it just,
Well, if you look at the 1-2, there's another dam that, let me just bring that one up real quick. It was one that I showed a few places, New Creek Site 14.
Mhm.
And when we were just doing the assessment of that one, it was Andy Dykert that said, Paul, I want you to look at this. And then I remember standing at the abutment of the dam. And he says, do you see what I see? He didn't tell me anything. He says, do you see what I see? And I'll just show you what he saw. Yeah, right here. So we were looking at this dam, and here's the auxiliary spillway off to the left abutment. And it was designed to do that. And, water doesn't like to make a 90-degree turn. And it also had problems with not enough spillway capacity. So what Andy was concerned about is, Paul, what if this happens? It goes down and it rides up this hillside, and then it comes back and takes a bite out of the dam, because that spillway had never been activated. And if you look at the topography, here's the embankment. It's a monster. It's over 100 feet high. And here's the spillway. And would the water really do this? Or would it do this and then erode and then come back and erode the embankment? So we'll
Looks
never
like
know.
looks like the same situation, except that we had a road instead of a hill.
Yep. And then the solution here, so that's what they wanted the flow to do, at this site. And we showed this, but the solution there was to see if I can get to the bottom here. Yeah. So it was, oh, darn, one more time. Here we go. Oh, it doesn't want to do it. So I'm going to just race down this way, cut through all this stuff and get to the, here we go. All right. Oh, I went too far. Here we go. Now, that's what the before looked like, right? That's was the existing conditions. And then the spillway was modified like this. So now you can see the flow, the control sections here. Once the flow goes down, it's beyond the toe of the dam, it's just going to keep going. But before it was like this.
Yeah. Realign the control section and let it get away.
Yes, exactly. But that same situation that you described and that you designed for, I think could have happened here. We just will never know because it was never activated.
It looks like you had the possibility.
I think so. And I wonder how many of these spillways have that possibility. My guess is probably about 2 or 3%.
It's possible there'd be that many, maybe more. And they just haven't come around like that one did.
Mm-hmm.
I just thought that was a creative solution to it that we came up with. That we had
you saw the road problem too, right?
Yeah, they were out there fighting their problem and we were looking at our problem, and I did a little quick math and figured out it was cheaper to do one dam than it was to do a dam and a road fill. Saved us money and saved them money.
Yeah.
And got a nice bridge. And
very well done. You must be like Elon Musk. That's how he thinks. He says every structure has to have multiple purposes. If I'm going to build a car, every part of the car has to serve multiple functions.
No, I was just in a panic as how we were going to fix it. I work as a planning engineer, and I was just worried how we were going to fix that one.
Well, you did a good job.
I will tell you, we actually had Larry Caldwell worried over that solution.
Really?
I finally came up with something wild enough to panic Larry Caldwell. You think that's not an accomplishment? You haven't worked with Larry Caldwell.
All right.
Thank you. It was a very good presentation.
You're welcome.
Rick, you better quit while you're ahead.
I'm going to. I'm
Get-
going
being
to.
compared to Elon Musk and panicking Larry Caldwell all in the same 2-minute segment. This might be a pinnacle for you, buddy.
I'm done. There's nothing more I can do on this live. I'd like to thank the Academy and
Hey, I did find something here. I found the presentation I was looking for before to show that chainsaw thing. I don't want to beat
This
it.
particular project is a dam owned by the city of Tyler,
It's,
and we were.
I won't talk over it. Is the video playing? Ray, you're on mute.
Yeah, we've gotten the video.
Okay.
Project was DeWind. The reason we approved DeWind.
Yeah, just to see what it looked like in action.
Mhm.
Yeah, who knows where the next invention is going to come from? In my career, this didn't exist. Articulated concrete blocks didn't exist. Roller compacted concrete was just starting when I started. The HydroPlus fuse gates didn't exist. Rubber dams were just coming into their own.
That is one large piece of equipment.
This is one where they had a groundwater problem and they didn't want the contaminated groundwater to go from one part of the watershed to the other part.
Huh.
So they just built a wall.
I'll be darned. While that's running, I don't know that you can go to a different spot, but Mark's asking whether or not you got a picture of a fuse gate.
Oh yeah.
Let me go to Mark here and I'll pop him into the discussion. So.
I'll get right there.
Hey, Mark, you got us?
Yes. Yeah, I was just wondering, he mentioned that, and I'd heard that from Water Management Center on some other dams across the country. I've never seen one, and he mentioned it, so I wanted to see what it looked like.
What does a
Sure.
fuse gate look like? Sure. That's good.
I'm almost there.
We're really testing Paul's skills here and moving him around his computer, but aren't we all convinced of how much resources Paul has? This is pretty incredible.
All right. They're basically tipping gates is what they are, and they come in all different kinds of shapes and sizes. It's a way of getting additional spillway capacity. Like here they had an OG spillway and they scalped it down to a broad crested weir so they could get past the problematic flood without overtopping the dam. But then they wanted their reservoir back, so then they put the tipping gates on top. And here's a nice video. Ray, is the video still playing? Can you
Yep.
see it?
Video's coming up. Mhm.
What's nice is it's the labyrinth spillway under normal conditions. And then it's not until you get something like the 5,000 year flood or something really, really remote that the reservoir will come up. And this is insanely stable until the water level gets above the well. And each one of these has a different elevation. And then once the elevation comes up, it'll surcharge, it'll flow down the well, it'll exceed the capacity of the drain, and that will create an uplift, and it will go from being very stable to very unstable. And then it just tips, and then the next one. And if it goes down, it's okay, otherwise it just tips. So it's like a fuse plug, but it's highly engineered and very precise and predictable. So that if you had a big spillway, you can have many of these, and that way it's just little increments of additional spillway capacity as the flood progresses. So the one to watch here is the one on the right, and then only that one will tip, and then if the flood goes away, you just replace it. If it gets worse, there's another one. This is a project that the first time I used them on a project was this one.
and we made them out of concrete. And you just stack them on the control section all the way across. And they're really designed never to tip. I mean, the kind of event that we would need for them to tip would be like a 5,000 year event. It's like a half PMF event. And then you can get them straight crest as well, same thing. You know, each one's designed to be unstable under different flow condition.
So what
And
was
then you-
the decision criteria, Paul, to put something that would only be used every 5,000 years on a structure like this?
Well, on this one, here's what they said.
Yeah.
You cannot change the normal pool.
Hmm.
You cannot change the top of the dam.
Oh.
You cannot change the stage discharge relationship of this dam up to the 100-year flood.
Wow.
And you have to pass 60% more flow.
Wow. Huh.
So how do you do that?
That's how you did it, huh?
The only way you can do it is with a gated spillway or a controlled spillway.
Hmm.
But we didn't want a mechanical gate, you know, there with all kinds of moving parts that
Mhm.
would never be used.
Right.
So the perfect solution is a fuse gate.
Doggone. That's a decision criteria is so important on these decisions, right? In the
Oh yeah.
preparations. Hey, Mark, what's your observation there?
Well, yeah, like I said, it was, you know, the cost of that, and just kind of curious where that comes in. On our case, it came in discussing, you know, land rights to top a dam, specifically on rehab projects where you have development upstream and you're kind of raising stuff up to get that rehab structure in there, and obtaining land rights all the way to those very infrequent storms just, you know, economically didn't make sense to go out there and try to get those land rights for that last portion to get to the top of dam. But, you know, to have some sort of gate like this that would function and not rely on some sort of manual structure to go out there and lower things when those events happen. So they mentioned fuse gates and ping, and I just couldn't picture it. So I appreciate the pictures and the discussion on it.
Yeah. Where's home for you?
Texas.
Okay, these are good in Texas. In cold climates, it gets a little more complicated because you have ice forces that can push on them as well, and you have to make sure you design for that. But I don't think you have that problem in Texas.
Not usually.
Yeah. That's a good point, isn't it?
Yeah, we worry about ice thickness of about 2 feet. That gets tricky because that can really push on something.
Mhm.
Texas about once every 5,000 years.
And then-
About the time they operate, right?
Yeah, that's right. There you go. Folks, don't miss this opportunity. If you're listening in, throw a question up there on the question and answer thing, throw your hand up, you know, using the one of the 3 items you got on that Zoom dashboard. We'd happy to visit with you. And again, Paul, how can we thank you? You know, this is phenomenal to have you stay over.
Glad.
Mhm.
Yeah, my pleasure.
So let's keep this going. If you have something, just put it in the questions and answers, or raise your hand. Either way is
Ray.
Mhm.
Ray, when we started, what did we get good attendance? I wasn't watching.
Yeah, I took a few notes for you, and Dan, we hit a high water mark, excuse the pun here, of 189 folks. And I can shoot you an attendance report too. Again, no time to go in and see how many of the states were represented, but if it's close to our registrations, right, we had everybody there, and some folks.
That's great.
Yeah, very, very good, very attentive. Okay, so here we got a question, Andy, coming in. I'm gonna pop you up here, Andy, so you can describe this a little bit too. Similar dam config to the configuration to the NC14 at North River, 81C in Virginia. Info from the D Temple. So let's get Andy on here and have him visit with us a bit, shall we?
Andy Dykert.
Yeah, Andy, hang on.
That's
Andy.
great.
Mm-hmm. We'll get Andy up here. All right, Andy, let's see if we can pop you in here. All right, Andy, come on in there. Andy, we got you online? Yep. Sometimes we have a little bit of a lag in between. Andy, let's try this one more time.
Ray?
Yeah, gotcha.
All right. I just wanted to point out, I think there was a dam in Virginia in the past that was configured similar to New Creek 14, as Paul described in his presentation there, that did have auxiliary spillway flow that did come back into the embankment, you know, as a result of the flow hitting the hillside. And Daryl Temple provided that information. So, and I think there was a short paper and photos with that write-up, and then Paul had that too.
Wonderful. Thanks, Andy.
Thanks, Andy. Appreciate it. Again, you're in the extra innings. I got a baseball right here. Yeah, I don't know whether you can see it or not. Yeah, extra innings with Paul in our webinar today, post-webinar. Appreciate all of you joining us. Appreciate those of you that have stayed with us. Kind of do a mini countdown here, and from 10 to 0. And if we hear no one else, and we'll probably be closing today. And anybody else? 10 and 9 and 8, 7, 6, 5, 4, 3, 2, 1. Okay. Paul, I think it's time for you to go eat some ribs, have a favorite drink in front of you, whatever that might be, and just enjoy the glow of a wonderful webinar today. It was
Good.
Really fabulous. And the extra innings, we don't get to do that very often, so that was wonderful too. So thank you so much, Paul. Dan, you better close us out.
Yep. Job well done, Paul, and certainly appreciate everybody, even Rick, chiming in for the extra innings and to hang with that baseball business. Paul, I think you hit a home run. So
Yes,
good to have you. You guys kind of keep your ears on for the next NWC event. And we sure appreciate your time. We don't ever take that for granted. And hopefully you all have a wonderful weekend. Thanks so much.
Thank you.
Thanks, folks. Ending the webinar now.